Hey everyone, and welcome. Today we're going to dive into a tool that is honestly one of the cornerstones of turning data into actual decisions. We're talking about linear regression.
Okay, so let's start with a question you've probably asked yourself 1,000 times. You're looking at this absolute sea of data. Reports, spreadsheets, you name it. How do you actually take that mountain of information and use it to make a smart, confident call about the future? So, to get our hands dirty with this, we're going to use a really classic example that anybody in business can relate to. The goal? It's simple, but it's a huge one. Can we figure out how many products we're going to sell based on what we spend on TV, radio, and newspaper advertising? All right, so let's get started, and we're going to begin with the simplest approach you can possibly imagine. Literally, we're going to try and draw one single straight line right through the heart of our data. And this idea has a name, of course. It's called simple linear regression. Just picture it. You've got this cloud of data points on a graph. What we're trying to do is find that one single line that slices through the middle of that cloud and best shows its general direction. It's a surprisingly elegant way to map the relationship between one single input and whatever it is we're trying to predict. Okay, so how does this magic actually happen? It's really a three-step dance. First, you just plot the data. Put your TV ad budget on one axis and your sales on the other. Second, and this is the cool part, you use a method called least squares to draw the best possible line. Basically, the math finds the one line that minimizes the total gap between itself and every single one of those data points. And third, once you have that line, you can make predictions. Just pick a spot on your TV budget, follow it up to the line, and bam, there's your sales forecast. Now, once we have that line, the model spits out two key numbers that tell its whole story. First step is the intercept. That's basically your starting point. It's what you'd sell if you spend absolutely nothing on TV ads. Then there's the slope, and this is the real powerhouse. It tells you for every extra $1,000 you drop on TV, here's the sales bump you can expect to see. It's how steep that line is. Right, but you're probably thinking, life's not that simple, is it? And you're absolutely right. Sales are rarely driven by just one thing. It's time we looked at the whole picture. And that's where we bring in the big guns, multiple regression. Instead of just looking at TV ads, now we throw everything into the mix at once. TV, radio, and newspaper spending. We're going from a grainy black and white photo to a full-color, high-definition picture of what's really going on. And this introduces a really, really powerful idea, controlling for variables. By having everything in the model together, we can see the true independent impact of each one. It's like it makes sure that TV doesn't get all the credit for a sales spike that was actually driven by a great radio ad. It helps us see the real MVP for each dollar we spend. Okay, so we've built this fancier, more complex model. Awesome. But, and this is a huge but, how do we know if it's any good? I mean, can we actually trust this thing to make real decisions? So first things first, we have to ask the big one. Is there really a connection between our ad budget and our sales? Or did we just get lucky and find a random pattern in the noise? Is it a real signal or just a fluke? Well, we have a tool for exactly that, and it's called the F statistic. And in our case, the S statistic basically screams yes. It tells us the relationship is real, it's statistically significant. The bottom line, our model has definitely found a genuine pattern. It's way, way better than just guessing. Okay, fantastic. So the model isn't garbage. But now let's get down to brass tacks. As a business, where do I spend my next dollar? Which of these channels are actually moving the needle? And this is where the model delivers the million-dollar insight. It shows that both TV ads and radio ads have a strong, positive, and statistically significant impact on sales. But newspaper ads? The model's basically shrugging its shoulders. The effect is so weak, we can't be confident it isn't just random chance. All right, we're almost there. Just one last check on our model's quality. We know that there's a relationship, but how strong is it really? I mean, how much of the sales story can our advertising budget actually tell? And for that, we look at a number called R squared. For our model, it's sitting at about 90%. And that is an amazing number. What it means is that our ad budget, just those three things, can explain about 90% of why sales go up and down. For a relatively simple model like this, that is an incredibly strong result. Okay, but hold on. Before you run off and call the newspaper to cancel your ad spend for good, we have to talk about some absolutely crucial words of warning. Understanding what a model can't do is just as important as knowing what it can. Seriously, if you take away only one single thing today, let it be this. Tattoo it on your brain. Correlation does not imply causation. It is the golden rule of all data analysis. Look, what our model has shown is a powerful link, a strong association. When TV and radio spending go up, sales tend to follow. But it has not proven scientifically that one causes the other. There could be something else we're not even seeing that's driving both. And there are a couple of other classic traps. One is called multicollinearity. That's just a fancy word for when your inputs are all tangled up. It's like trying to figure out which of your two guitarists is the loudest when they both turn their amps up at the exact same time. It gets muddy. And, of course, don't overinterpret. Remember, the model gives us great estimates, but they aren't gospel truth carved in stone. So, what's the big takeaway here? Linear regression, it turns out, is this simple but incredibly powerful way to find the signal in the noise and turn data into direction. And that just leaves us with one last question for you. If a simple straight line can tell us this much, what incredible patterns are just sitting there in your data, waiting for you to find?